Okay. The next section has to do with proportional lines still, but it's a little bit easier than what this section was. You've got parallel lines, and parallel lines, when you draw on a triangle, cuts it into proportional segments. So on page 307, there's the triangle proportion theorem. If a line is parallel to one side of a triangle and intersects the other two sides in two distinct points, then it separates these sides into proportional segments. So basically what you're saying is this. If I've got a parallel line right here, okay, it's parallel to one side of the triangle. Let's say I've got A, B, C, D, E. There's two different ways to do this. One way is you stick to one side and you go, oh, AB is to BC, okay, this is to this, as this is to this, okay? So left bottom, left top, right bottom, right top, okay? Now the other way to do it is go, oh, I want to compare the bottom to the top, and I go AB is to DE as BC is to DC, okay? If you'll notice, it actually ends with, if you cross product, AB times DC is DE times BC, which is the exact same thing I have up there. Okay, so some people see it better if you just stick to one side and do bottom, top, bottom, top. Some of it go, oh, well, that's comparable to this, and that's comparable to this. But in the same sense, this is the other thing I can do on these. I can say a part is comparable to the whole, so BC is comparable to AC, as CD is comparable to CE, okay? I think you would probably see it left and right, but I don't know that for sure. It's kind of hard to mess this up, okay? The converse of it is true. Well, here, let me show you one. Let me show you one that you would do a problem on. Now, for these to work, you got to have a parallel line, and they're going to tell you it's parallel, okay? So I have EF, and I have HL, and those two lines are parallel, and then I have a G down here. And it tells me that HG is 21, and it tells me that EH is 9, and I know that FL is 6, and I'm trying to find that, okay? Now, again, I can choose to go left, right, or I can choose to go top, bottom. If I go left, right, I can go 9 is to 6 as 21 on the left is to my question mark on the right. Or I could go 9 is to 21 as 6 is to x. Notice it's going to give you the same answer. Okay, so it just has to do with how you see it. Okay, so if I cross product here, I have 9x is equal to 126, 14 times. Okay, so that x right there is a 14. Okay, in a way it's easier because I can't turn these things, because everything has, you've got to have parallel lines, so they can't do one way and one the other, which is what made that other part so difficult. The reverse of this is true. If a line intersects two sides of a triangle and separates the sides into corresponding segments of proportional length, then the line's parallel to the third side. In other words, if they didn't tell me that this line was parallel and I knew that this was 14, I could go, oh, I want to know if that's parallel to that. And the way that I could do it is go 9 is to 21 as 6 is to 14. Are they proportional? If I reduce them down to a decimal value, I would get the same decimal value on both sides. So I would know, yes, they are. So therefore, this line is parallel to that. It's just the reverse of that other theorem. Okay? I'm going to give you one to try. Like I said, I find these easier because I can't turn the triangles on me. Okay, they tell me that those two are parallel. This is x, or this is 8, this is 12, this is x, and this is 3. Find x. It doesn't come out in the whole. 4.5? Mm-hmm. Exactly. Okay. Draw this one. This is another example of what you might end up doing with these. Okay, they don't, whoops, man, my drawing's terrible. Okay, they don't tell me they're parallel, but they give me a lot of information here, and that's what you're trying to determine here, whether it's parallel. Says HM, which is this whole thing, is 15. Says HN is 10. And it says HJ is twice the length of JK. So if I call this X, this would be 2X. Okay? So this is going to be one of those, you could do a part to a whole, or you could say if this whole thing is 15, what is this? 5. That's going to be 5. Okay? So I can go 5 is to 10 as X is to 2X. If I reduce that down, I get 1/2. If I reduce that down, I get 1/2, which means that has to be parallel to that. Okay? Those are kind of some of the problems that they're going to ask you to do. All right, then there is this kind of a cool theorem that says, it's called the triangle mid-segment theorem. So if I have a triangle, and it says a mid-segment of a triangle is parallel to one side. Now, mid-segment means it's right in the middle. It's the midpoint of both of those. Now, that doesn't necessarily mean that this is congruent to that, but it does mean that this would be congruent to that. So that and that are congruent. This and this are congruent. And it says if that is parallel to that, okay, then this measure is half of this measure. So if that's 5, this would be 10. If this is 20, that would be 10. Okay? So this is exactly half of what this is. Okay? Now that's only if I have a mid-segment. Okay? And that mid-segment is parallel to one of the sides. So this is what it's going to say. And then we're going to turn and put this on a coordinate plane. I'm looking for one like this. I don't even know if they give you a normal one. They just go ahead and put it on a coordinate plane. So that's what we'll do. triangle ABC has vertices -4, 1, 8, -1, and -2, 9. DE, and they have a DE like here, like that. They don't have it on a particular point. DE is the mid segment, okay, which means this has to be the midpoint and this has to be the midpoint, okay. It says find the coordinates of D and E. You remember how to find the midpoint?
Add the 2 and divide by 2.
Exactly. So this is going to be +6 divided by 2, so that's going to be a 3. 9 and -1 is 8 divided by 2 is 4. So that's the point 3, 4. Down here I have the point, let's see, 4 divided by 2, which is 2. And how about 2, 0? Okay, so that's the very first thing they asked me to do. Then it says verify that AC is parallel to that. Okay, now tell me it was the mid-segment, which means to be parallel, for one thing, I could do this a couple different ways. I could use slope formula, because the slope of both lines that are parallel are the same, remember? So I could find the slope of this and I could find the slope of that and verify that it's parallel. So let me do that. Remember, that's the difference in the y's. Okay, so I have 9 minus 1 over -2 minus a -4. So that's going to give me 8 over +2, which will be 4. That's the slope of this. So let's see on this one. 4 minus 0 over 3 minus 2 is 4 over 1, or 4. So yeah, I just verified that that is parallel to that. Then it says verify that this is half the length of this. And you would use your distance formula. Okay? Hopefully it's found in that calculator. So I have so the distance here is like 8.24, or actually I think it rounds to 2.5, and then the distance there is 3, 4, 2, 0, 4.12. And so because I rounded, I know that that's close enough to say, yes, this is half what that is, okay? One last thing, okay? There is on the bottom of page 309 a corollary that's very similar to what we just did on a theorem. And it basically says this: if 3 or more parallel lines intersect 2 transversals, so here's 1, 2, 3 parallel lines, okay? Then they cut off the transversals proportionally. So in other words, it's like the one we just did, okay? AB is to BC as EF is to ED.
Gotcha.
AC is to BC. I can take any part of it. And as long as I compare it, I can take the whole is to the bottom. AC is to BC as FD is to EF. Okay? I can, I can take any portion of them as long as I keep them with the part that looks like it on the other side. Okay? Let me show you one of those real quick. This is all very, very similar, even though they're all under different corollaries. Okay, here's my 2 transversals. And then I have 3 parallel lines. Okay, this is 3x minus 4. This is 6 minus 2x, and when I say that's the line from there to there. This is 3y, and this is 5 over 3y plus 1, okay? So I can sit here and I can go, whoa, and I got this, okay? That actually literally cut it exactly together, so I can first solve for the x by putting these two together. Now, I don't know for sure that those are going to be the same, so I can't assume that if it doesn't have a line on it. So I can say, but this one already has a congruency mark on it. That is equal to 6 minus 2x, and I can solve for x, right? So I'm going to add the 2x, so I have a 5x. I'm going to add the 4, so I have equals 10. X is equal to 2. Okay? Now I can plug those in and find that measurement. So I have 6 minus 4, so this is a 2. Let me verify here. I have 6 minus 4, so this is a 2. Okay? So I could say, literally, the way that I did that, 2 is to 2 as 5/3 y plus 1 is to 3y. So I can cross product this thing, but is that not a 1-to-1? So therefore I can turn around and go 3y is equal to 5/3 y plus 1. Probably the easiest thing to do is multiply everything by 3. So I have 9y is equal to 5y plus 1. So I have 4y is equal to 1, or y is equal to 1/4. Okay? I feel like I did something wrong. Oh, I forgot to multiply this one by 3. I knew that didn't seem right. There we go. 3/4. Okay. Does that make sense? It's all a very similar theorem. That if you have parallel lines, it's cutting the sides off proportionally. They cannot turn it on you because they have to have the parallel lines. Turning it was the big problem on the last one. Okay, for you and me both. Okay, so I want you to do for homework, page 312 through 313. And I want you to do let's do 14 through 26 even. And then